Good afternoon. Shall we wait for the others to join in? I think few are yet to come. Hi, good afternoon. Are the others going to join in, or is it just these many of you? Ah, okay, people are joining in. So, did you all do sums yesterday on polynomials? Yes. Okay. Did you find it a bit easy? Were you able to do it, or there is still doubts as such? It was better after revision. That's nice to know. Okay, so today what we'll do is like yesterday, I'll just cover the different concepts which come under number systems, right? Then you can practice that also. Okay, so then it will be easier. Okay, I think most of them are here. They are still joining. I'll wait for another 2 minutes. Let them join. Yeah, that's fine, Aditya. As long as you have solved the questions, is fine. This was a revision session, right? So I just want you all to solve and build your confidence that yes, you can do it. Okay, so chalo, today we'll do number systems. Okay, so number systems, the first things that you need to keep in mind are what are natural numbers, whole numbers, integers, real numbers, right? You're familiar. Yes, Shakti, I was going through the worksheet you sent, and yeah, once I finish with this class, there are two questions which I found a bit difficult, so I'll discuss them. After I finish number systems, I'll discuss that. Okay, so who's going to tell me what are these different terms that I've written? Anybody? Ah, I see somebody's raised their hand. Okay, that's nice. Let's see. Tashvi, yes, tell me.
So natural numbers are the numbers that are between from 1 to infinity. Whole
Okay,
numbers are the natural numbers with 0 included.
okay,
Integers are the numbers from that come before, so like that come before the 0, which go by -1, -2, and from the other side as well, which is +1, +2, +3, and so on.
okay.
And real numbers are the numbers that okay, I'm confused with real numbers, but
Real numbers is the set of all of them. So integers will include a negative from negative infinity to positive infinity, right? And real numbers will be the combination of all of these terms. So the remaining fractions, the decimal values, or you can say that, right? All those will fall under real numbers. So these three, basically these three are subsets of this, of real number. That was nice. So okay, people have answered here also. Atharva, yes. Netri has also answered. Elena has answered. Ria has answered. Nice. Good going. Okay, so you are well aware of all these things, right? Next part which we need to clear is what is uh, rational numbers and irrational numbers. So who's going to tell me about rational and irrational numbers? Okay, Ritvik.
Ma'am, rational numbers are terminating and recurring or non-terminating recurring.
Okay. Or is there a standard way to say
Then
that? Like,
they are in the P by Q form.
yes, awesome.
And
So
Q
P
is
by
not
Q
equal
form
to
where?
0. And Q is not equal
Yes,
to 0.
correct. And irrational numbers?
And they are non-terminating and non-recurring.
Okay. Okay, so you are clear on rational and irrational numbers too. So this is P by Q form where Q is not equal to 0. Okay. So basically in this chapter, the first kind of questions you might get is to identify, like polynomials, you identified the polynomials. So similarly here you will get identification of numbers, whether they are rational numbers or irrational numbers. So like Ritvik said, there are going to be terms like terminating, which means the decimal expansion stops at a point, right? There is going to be another term is called recurring. This means that some part of the number after the decimal point is being repeated. Like for example, 1.272727, which can also be written like 1.27 bar. So this is a recurring, right? So there are two. Let me write it like this. One is going to be terminating, recurring. Okay, what I will I just scroll up. Oh, hmm. Then there is something called terminating, non-recurring. So basically, I'm just putting these two terms in like all probabilities, right? And then there will be non-terminating, recurring, and my final one will be both non, I'll just put this double quotes, and non-recurring, right? So out of these, this one will fall under irrational, right? Okay. What is the definition for irrational number? Basically, any number which is non-terminating, non-recurring, Shakti. So the rest three combinations will be rational numbers. So now, since you know this, can you tell me is pi a rational or irrational number? Who's up for explaining that? Irrational. Nice. Okay, Raghav. Tell me.
Ma'am, a pi or a pi
Hmm?
is a, irrational number because it's non-terminating and non-recurring.
Okay, but we take the value as 22 by 7, right? Then?
Yes, ma'am. Ma'am, there's the approximate value, and that's not the proper value.
Okay, yeah, that's right. So we consider pi to be 22 by 7, right? Let me write it here. The case of pi, right? We consider the approximate value to be 22 by 7, but the real value is 3.14, and set of digits after this which fall under this category, that is they are non-terminating, they don't end, and non-recurring, which means they don't repeat. There is no pattern as such. Okay, so hence pi falls under the irrational number category. This is one of the questions which is asked repeatedly, I guess. So it's good if you know, so you don't get confused when they say that, it's we take it as 22 by 7, then that's p by q. This p by q form, right? Where q is not equal to 0. This fits the definition of a rational number, but this is just an approximate value, the keyword, right? So Raga has given the correct answer for this. Okay, let me clear the screen. I guess things from yesterday's class are also here. Okay, so that is one type of questions, identifying. So shall I quickly take up questions which involve identifying? Okay. Mm, yeah, here. Classify the following numbers 1.2.25. Classify the following numbers as rational or irrational. Root 23. You can just say, yeah, you can just type R or I. You don't need to type the whole thing. Yeah. Okay. Raghav says rational. Why is it rational, Raghav? The first one. It's root 23. Oh, Elena, I took up an example of 1.1.25 and I am asking you all to tell me whether it's rational or irrational. Okay, the first one, which is root 23. Root 23, is it rational or irrational? Okay, yes, it's irrational. So no doubt in that, right? Why is it irrational? Because the expansion of what you say, if you do long division for root 23, you end up with, it's not a perfect square. There is no square for 23. So it will be, the expansion will be non-terminating, non-recurring, hence it's an irrational number. What about root 225? Let's go one at a time. I'm getting confused with the answers otherwise. Yes, so it's rational. Correct. Atharva, yes. Yep, rational. Okay, so if you look carefully, 225 is the square of 15, right? So the square root of 225 is 15. Hence, it's going to be a rational number. What about 3796? How are you going to identify that? Somebody says irrational. Puneet says irrational. Why, Puneet? Okay, Puneet changed it to rational. Okay, yeah. So 0.3769 can be written as 3796 can be written as 3796 by 1, 2, 3, 4 zeros, right? So it can be written in the form of P by Q. Hence it's a rational number. What about the next one? Fourth one. Fourth one is irrational. Puneet, are you sure? How many of you say fourth one is irrational? Nobody. Only few of you are answering. What about the rest of you? Are you all stuck somewhere? Do you need help? Neki says irrational. Neil says irrational. Fourth one. I am asking the fourth one, Abir. 7.478478. Is it rational or irrational? So if you look closely, 478 is recurring. There's a pattern. 478, 478, right? So this does not fall under the category of non-terminating, non-recurring. This is not non-terminating because of the three dots, but it's recurring, right? So it's going to be a rational number. And what about the last one? On the similar lines, think about the last one. Raghav, last one is rational. Ria also says last one is rational. Okay, look carefully. Do you find a pattern? Oh, okay, this one most of you are answering. Yeah, so if you look carefully, you will see that there is no pattern. Like first there is 101, then there are two zeros, then one, then there are three zeros. So it's non-recurring. There is no pattern, no repetitive pattern. Basically, recurring means repetitive, right? So there's no repetitive pattern here. So it's an irrational number. Okay, nice. Anybody still having confusion on how? So this was just a small example. They might ask you tricky ones, mostly involving square roots or decimals. Or... Anybody still having a doubt? No? Okay. So just remember, like if you get square root, it's easy, right? So if it's not the square of any number like 23, if it's a prime number, or if it's not a square of any number, it falls under irrational automatically. So check once. Hmm. And in case of decimals, you can just, if it's zero point 0.3, like 0.396, you can just add zeros, right? You shift the point and add zeros in the denominator and expresses as p by q. So you can see it's, you can write it as p by q. So it's going to be rational. Okay, so you got this, right? Okay, so the next part, what we are going to take up will be, interesting. Okay, so we covered the first kind of questions. The second kind of questions is finding rational numbers between two numbers. So this can be done in multiple number of ways, right? There's no one method of doing this. What are the different ways of doing this? Either take average or take LCM, or if it's decimal, or convert to decimal. Right. So for example, if they give you, let me take this one. Yeah. So for example, if they give you find rational numbers between 3 and 4. So what you can do is you can take average like 3 plus 4 by 2. So you'll get 7 by 2. So then the next number you find between 3 and 7 by 2 and 4 and 7 by 2. Then the next the number you get here, you use that and again you get. So as many numbers you require. Suppose they say 5, so you will get 5 numbers here. Or since it's direct, you can just say, since direct rational, you can just add 3.1, 3.2, 3.3, 3.4. If they even want more, you can go to 3.11, 3.12, and so on, right? Convert to decimal will be in the cases they ask you fractions, like suppose they ask 7 by 2 and 3, some, let's say, there is one example, right? Yeah, there is one example here. Yeah, rational numbers between 3 by 4 and 4 by 5. In that case, you can convert them to decimal and then search, right? Abir has a doubt in rationalizing. Yes, I will cover that, Abir. Don't worry. This for now, we are just working our way towards those concepts, right? We'll cover the simple topics first and we'll go to rationalizing also. Okay, so this is easy, this is clear. Oh, sorry. Yeah, where is the whiteboard? Yeah. So is this clear? This method, if they ask you. So now I'm going to ask you all one question. Okay, tell me the answer to this. There's only one answer to this. So I want. Tell me how many. Let me write it here. How many rational and irrational numbers fall between, let's say, 3 and 4, right? Who's going to tell me? How many numbers fall between, how many rational and irrational numbers fall between 3 and 4? Awesome. Puneet and Ryan, Ritvik have already answered. Nice. Dhruv, Shakti, yes. I want all of you to answer. This is easy. Netri, yes. Aditya Mundra, yes. Neil, yes. Abir says 9. Why 9? Divya says 10. Abir and Divya, can you all explain your answer? Elena, yes. Neki, yes. Atharva, Abhishek, yes. Shivesh, why do you say 8? So I'm asking you between 3 and 4, how many possible? I'm not asking for a number. I just want to know how many possible rational and irrational numbers can fit between these two. Shivesh says 9. How, Shivesh? Okay, whenever they ask you such a question about how many rational or irrational numbers fall between 3 and 4 or fall between any two numbers, let's say 7 and 12, right? The answer is always going to be infinite. Okay, because between 3 and 4 itself, like I said, if you want rational numbers, you will have 3.1, 3.2, and so on, right? If you want more, you can go to 3.11. Then again, you can go one more step ahead and go 3.111, right? So that leads to an infinite number of uh, numbers, like infinite numbers, which fall under between either two numbers or a greater stretch of numbers, anything. So the answer to this is always going to be infinite. So never sit and calculate. Okay, write this down somewhere if you are going to take notes. So these are the key points I want you to remember before you start solving questions. Okay, that's why I'm taking this. I'm writing all these things down so that before you start solving, you are well aware on the different types of questions which are going to come your way, so you know what to do. Okay, done. Awesome. Then the next thing we'll do is, yeah. So we covered irrational, rational numbers, how to find them. So the third type, okay, what happened to the pen? Yeah. The third type of question is expressing recurring decimal number in the form of P by Q. Example. Let's take an example. Be easier, right? Okay, so we'll take the first example of this. Yeah, right here. We'll take 0.333, then I want you all to do the next one. Okay, so example is 0.3333, or it can be also written as 0.3 recurring. Okay, so what are the steps you do? First thing, assign x as that number. So let x be 0.333. Second step, what do? You see after how many places is the repetitive pattern occurring. So in this case, it's just 1, right? Somebody has a question. Okay, y'all are giving me answers. That's nice. So just let me do it once for those of you who need a revision. Then I'm going to give you all one question to do on your own. Okay, so this place, if you see, after one decimal place itself, the pattern is recurring. So what do? You multiply 1 with 10, right? Because it's one place, so 10. If it was 2 places, you multiply 100, 3 places, 1000, and so on. So you get the idea, right? What we're doing here. Okay, so it will become 10x is equal to 3.33, right? Because this is recurring. Okay, so now next step is subtract. So it will become 10x minus x is equal to 3.333 minus 0.333. So you will get 9x. What you will get here? You will get 3, or x is equal to 3 by 9. 3 by 9 or 1 by 3 is in the form of p by q. Hence we achieve what was asked. Right? Okay. Okay, Mansi is asking how to find numbers between two irrational numbers. So basically, if they ask you irrational numbers, Mansi, what you can do is like they give you, suppose, let's say, let me write it here. Suppose they give you irrational numbers between, say, 7 and 12. Okay, so what you can do is write down how many squares fall under this. So only one falls, right? So root 9 is a perfect square of 3, right? 3 square is 9. So root 9 will fall. Okay, I'm going to confuse if I write like this. Yeah. So basically 9, excluding root 9, all the other roots like root 7.1, root 7.2, root of say 11, all these are irrational numbers. So it depends on how many they ask you. All you have to do is ensure that that number you have written under this square root does not have, is not, does not have a sign like square root of 9 is 3. It should not be simplified further. As long as you can't simplify it further, it falls under an irrational number. Okay, Mansi, is that clear? Okay, awesome. So you got this, how to express recurring decimal in the form of p by q. So I'm taking up the next question. So let's see who's going to answer first. So yeah, the next question itself. Show that 1.272727 can be expressed in the form of p by q. Who's going to tell me? Okay, Puneet, Ritvik, Mansi have given me the correct answer. Aditya Mundra, you are missing something. Muskan, yes. Neil, can you check once? Neil, something in your numerator is a bit wrong. Yes, Elena. Abir, no, in this both 2 and 7 is repeated. If you look closely, 2 and 7 is repeated. Shivesh, Atharva, are you sure about your answers? Atharva's answer is right. Shivesh, is it 4 and 7? No. Abir, so did you follow the steps which I mentioned? First, write it as x is equal to 1.272727. Then the next step will be, since two digits are multiplying, multiply both sides by 100. Raghav, can you check your answer? Aditya Mundra, yes, it's right now. Abir can't see the question. Abir, can you refresh your connection once? Is my screen visible to all of you? Yes, Shakti. Abir, try refreshing the connection. Okay, so I am assuming most all of you did the question, though I cannot see all answers here, but Raghav, check once. It's you're missing something in the numerator. Okay, so for those of you who have done it, shall I quickly write it here? How is it done? So it's 1.2727, or it's written as 1.27 bar, right? So you're going to write x is equal to 1.2727. Then multiply 1 by 100, because there are two digits which are repeating. After two digits, the repetition occurs. So it will be 100x is equal to 127.27, right? That will be 100x minus x is equal to 127.27 minus 1.27. This will be 99x is equal to 126, or x is equal to 126 by 99, right? Yeah, you can simplify this further. Okay, Netri, can you check your answer? How did you get such a huge number? Arav, yes. Okay, so is this clear? How do you express? So if they give you three decimals which are recurring, the number recurring after three decimal places, you're going to multiply by 1000. Can I do one more question? Okay, sure. Are you all facing difficulty in this? Take up the next one. Show that 0.23535 is repeating. So now how are you going to do this? It's repeating after 0.235. So be careful when you multiply here. It's repeating after the third decimal place, right? But 2 is not repeating. So what are you going to do? Yes, I'm getting answers. Puneet, yes, your answer is right. Atharva, are you sure? I don't think this is reducible. Rakshita, check once. Check your answer. Mansi, yes, I think there's a typo, but yeah, I think your answer is right. Aditya, yes. Neil, yes. I think we had covered these questions in the class when we had done number systems, right? Abir, are you solving? Did you get it? Yes? Okay. Okay, then we'll go ahead. So in this case, if you look closely, even though the decimal point is repeating after, like it's recurring after 35, and there's a 2 ahead, so 235, so you should multiply with 1000, right? The point where after the first repetition, so always ensure that, like, if it's 0.23535, so after the first repetition, which will be here, so you multiply by, there are three places, right? So you multiply by 1000. Yeah, and then simplify, you get 233 by 990. Okay, So I'll quickly move on to the next part. Okay, so we are done with that. Yeah, so the next thing will be decimal expansions. Write it in form of how, yeah, decimal expansions. This simple long division, there's nothing involved in this, right? Simple division. Like for example, let's take this example. What does it say? 10 by 3, right? So example, 10 by 3 express in the form of decimal, right? So what do? You just do simple division. 3, 10, 3, 3s are 9, 1.3, 9, 1.3, 3. So basically this is going to keep continuing. 3.33333. Okay. So whenever they ask you, yes, Netri, yes. So whenever they ask you decimal expansions, it's simple division. Don't panic or don't feel lost that what is decimal expansion. Simple long division, you will get the answer. Okay. But just be careful. Like here, be careful where you are putting the point, you know, just those kind of uh, simple errors, try to avoid them. Okay, so this was easy. Then we take up the next one, which is coming to operations on irrational numbers. So operations, okay, on irrational numbers. These are all very simple kind of questions. I think you might just get them for 1 or 2 marks for whatever I covered till now. Yeah, only the express the recurring decimal in form of p by q might carry, 2 to 3 marks or so. That is an important type of question. But the rest, like identifying rational or irrational, finding rational or irrational numbers between two given numbers, and decimal expansion are all simple questions, like very 1 or 2 mark kind of questions. And so is this operations on irrational number. Okay, so if I am going to give you something like 3 root 2 plus, uh, let's say, yeah, plus 5 root 2, you can add. Okay, you consider the irrational part as a variable, like let root 2 be x. In your head, this should be the way it goes, that the irrational part is considered as a variable. So the both these terms which I have written here have the same variable, hence can be added. And hence you can write, how do you add? You add the rational components together, so it becomes 5 and 3, 8 root 2. Okay? Yeah. What about this? Can you add these numbers? Can you add this? No. Yeah, right. So in this case, why no? Because root 2 and root 5, so this is like adding 3x plus 2y, okay, which is not possible. Correct? It will remain as 3x plus 2y, you can't simplify it. Okay, so if you get confused or if you feel lost whenever you see an irrational number, sorry, whenever you see an irrational number and you feel confused or lost, treat them like variables. Just in your head, assign them as variables, assign root 5 as a variable, and then see. Okay, they all have the same. So in this case, it is like 3x plus 2x. Hence the addition can be performed, right? So similar goes for subtraction, multiplication, Multiplication, yes, you can. If it's going to be something like root 3 into root 2, yeah, you can add it. It will be root 5. Oh, sorry, root 6. Yeah, multiplication, right? Or if they give you something like 6 root 3 into 2 root 2, yeah, if they give you something like this, what is it going to be? You multiply the rational components together, 12 into root 6. Multiply rational components together. Suppose if they give you something like, let me write it here. If they give you something like 6 root 3 into 7 root 3, then in this case it will become a rational number, right? 6 7s are 42, it will become into 3, or you can multiply, right? You'll get a rational number, correct? So, yeah, you got the hang of it, right? How do you operate on irrational numbers? Okay, then quickly tell me this. Let's just pick up one question. Uh, Divide 8 root 15 by 2 root 3. I'll write it here. Okay, so the question is divide 8 root 15 by 2 root 3, right? By 2 root 3. How are you going to go about this? Yes. Abhi, Mansi, Netri, can you check once your answer? Ritvik, yes. Puneet, Arav, yes. Elena, yes. Aditya Mundra, yes. Anirban, Neil, Sara, Shakti, yes. So you got it right. I just spoke about addition, subtraction, and multiplication. I didn't speak about division. So I just wanted to know. By 2 root 3. First you write it like this. Next step, 8. What you can express the root in terms of prime factors. In this case, you can write it as 5 into 3. Right? Still be 15. Now you can also write it as 8 root 5 into root 3 and 2 root 3. So root 3 gets cancelled. 2 4s are, your answer is 4 root 5. Okay. Simple, right? Neki, check once. Yeah. Ria, yes. Okay, so you got the hang of it. What do we do? When you're given a mix of rational and irrational numbers, how do you do operations on them? You've got the hang of it, right? Okay, so then we'll move on to rationalization, the part which is a bit tricky. Let's increase the difficulty level, right? Say rationalizing the denominators. Okay, we'll take an example and do this. Okay, so yeah, here 1 by root 7 minus root 6. Okay, so example 1 by root 7 minus root 6. Okay, always keep in mind you are going to use the identity here. Okay, this is the identity we will use always while rationalizing the denominator. Okay, so yeah, instead of remembering terms like conjugate, or if you find it difficult, like if it feels like a foreign word to you and you don't know how to correlate it, just keep in mind this formula. So always we are going to use a square minus b square is equal to a plus b minus b in the denominator. So if you look closely, this is already, I can say that this is a minus b, right? So what do I need to do? I'm going to multiply it with a plus b, so that I get, I'm going to multiply this with a plus b, right? So that now I can use this identity here. But since I'm multiplying the denominator by this term, I have to also multiply the numerator, right? Sorry, this is plus. Yeah, plus root 6. Correct. Next step is simplify. So it becomes, how do you write this? Root 7 square minus root 6 square, right? Or it becomes 7 minus 6, which is 1. So your answer will be root 7 plus root 6, right? Okay. Yes, you got it. So instead of, yeah, the right term to use here is you multiply with the conjugate. But in case you feel that, that's like a difficult word to remember or difficult to correlate here, like you don't really understand what is a conjugate in this case. So just remember this formula. A square minus b square, you are going to be using this in various chapters, right? Even polynomials. So this is an identity you are going to remember, right? So always see which part of the which part a plus b or a minus b will be given to you. So you just have to multiply with the other part. So let me, I'll just take up one more example so that you are comfortable. Okay, then you can solve on your own maybe. Okay, which should I take? Yeah. 1 by root, okay, there is nothing plus here. Okay, here. 7 by 3 root 3 minus 2 root 2. Okay, so I'm taking another example. 7 by, sorry, 3 root 3 minus 2 root 3 root 3 minus 2 root 2. So what are you going to do first? You see, this is of the form a minus b, right? So you are going to multiply with a plus b, correct? This is the first thing you do. So how will you write it? 7 by 3 root 3 minus 2 root 2. Multiply it by a plus b part, which is nothing but 3 root 3 plus 2 root 2. And since you are multiplying the denominator, you also have to multiply the numerator, right? Plus 2 root 2. So next step you get is 7 into 3 root 3 plus 2 root 2 by 3 root 3 square minus 2 root 2 square, right? So I just take this a bit up. Okay, so now 7 is there. You multiply it, only consider irrational part as variable. So this previous concept comes here in handy. So it will be 21 root 3 plus 7 to the 14 root 2. You don't multiply 7 with the variable. Treat this as a variable. Treat the irrational component as a variable. So you don't get confused whether you have to multiply it with that or not. Correct? And 3 square is 9, 9 into 3, right? Root 3 square is 3. And 2 to the 4 into 2. Root 2 square is 2. So it will be 21 root 3 plus 14 root 2 by 27 minus 8, right? And then you can simplify further. Okay. You can just leave 7 outside common and cancel it later. Yes. So you got the hang of it basically, right? What do you do for rationalization? Abir, question which comes for rationalizing part, like what do you say? That's one more step ahead, one more step of difficulty. So this is simple. This is just like you have to rationalize the denominator. One type of questions which you get is they give you a term, okay, and they equate it to, and they say it's equal to some a plus b kind of thing. So you need to find the, uh, I'll just show it to you. Give me a minute to search for the question. Uh, Something like this. If no, yeah, if root 2 is 1.414 and root 3 is 1.732, then find the value of this expression, right? So that is one kind of question, and there is one more. Where is it? Where is it? I can't find it. Yeah, here it is. So this is the type of question I was looking at. So let me take one of them. If 2 plus root 3 and 2 minus root 3 is a plus b root 3. Okay, this type of question is what I was talking about, which you might actually get if uh, uh, 2 plus root 3 by 2 minus root 3 is equal to a plus b root 3. Find a and b. Okay, so these kind of questions will be like application based. Oh, sorry, Shakti. Don't worry. I'll share the recording. Like yesterday, the recording is still under process, so I'll upload it by tonight. Yeah, and if this is ready, I'll upload it along with that. Okay, so you can note it down later. So in that, after getting the answer, we'll multiply it with the value. Yeah. So in this case, what do you do is first if you see this RHS, right? RHS is a hint that you are going to, if you solve the LHS, you are going to get some expression in this form, right? In this form of a plus b some irrational part, or it's going to be root 3 only. So you are going to get something on the LHS which is having numbers in place of a and b, and then by comparison you can just say a is this and b is. How do you do that? You work on the LHS part first, right? So don't there's nothing to be done with the RHS. So we work with the LHS and rationalize the denominator, right? So how to do that? A minus b component is there here, right? I'm just going to multiply it with a plus b component. Multiply the numerator also, right? So if you see, this becomes, what does this become? 2 plus root 3 the whole square, right? By 2 square minus root 3 square. Now this can be written as 2 square plus root 3 square plus 2 into 2 into root 3, right? 2ab by 4 minus 3. Or you will get it as 4 plus 3 plus 4 root 3 by 1, which is nothing but 7 plus 4 root 3 by 1, or just 7 by plus 4 root 3, right? So if I'm going to compare, so I'm going to write this statement here, comparing LHS with RHS, I can say that A is nothing but 7 and B is nothing but 4, right? B is 4 because root 3 is already there, right? You got it? So these are the type of questions. Yes. So there are plenty of questions in the workbook. Choose this if you feel whatever concept you feel you are weak in. Now that you are having these how to solve steps with you, right? So pick up those questions from the workbook. There are plenty, right? Of this type also there are plenty. Okay. So you pick those questions and try solving. Okay, Elena would like me to explain it once more. Okay, I'll take up one more example and explain it to you. Okay, is that cool? Okay, so I'll just quickly take one more example. Let me take the next one itself. It says 5 plus root 3 and 5 minus root 3. So, okay. Second example is root 5. Okay, I forgot the question. Root 5 plus root 3 by root 5 minus root 3 is equal to a plus b root 15. Find a and b. Some cases they might go one step ahead and ask you to find a plus b. Okay. If they ask you such question also, the process you follow is the same. So what do? First, rationalize, work on the LHS. Okay. So what do? So this is the a minus b part, right? So I'm going to multiply with the a plus b part, right? So what do I get? This is okay. Uh, so this is nothing but root 5 plus root 3. Okay, this is 3. Yeah. The whole square by a square minus b square. Get it? So this will be root 5 square. I'm just directly writing it this time. So 5 plus 3 plus 2 root 5 into root 3. So here, remember, if you are going to consider, if you consider uh, root 5 as x and root 3 is y, root 5 into root 3 will be nothing but xy. So this operation is possible, right? So that's why anytime you feel you are confused whether you can, perform operations on two irrational numbers, always treat them like variables. Just blindly substitute a or substitute xy or substitute anything you like, any variable you like. Okay. So hence, yeah, so xy is possible, so you can multiply this. Okay. And this will be 5 minus, okay, yeah, this will be 5 minus 3. So on simplification, I get 8 plus 2 root 15 by 2. I'm going to take common outside. So this becomes, because I want it in the form of a plus b root 15. I don't want a denominator. Or I can just split the denominator, right? Either way. This way or split the denominator. You get the same thing. 4 plus root 15 by 2. So it gets cancelled. Now if you see, oh, yeah. So on comparing with RHS, A is nothing but 4. And what is the value of B? There's no term before root 15. So it's going to be 1, right? So now there you got A and B. And what will be the value of A plus B? It will be 4 plus 1, which is equal to 5. Okay. In some cases, always remember, in some cases, you might just get the value of B, okay, as something. But A, there will be no component. No component. Okay, so in those cases, write A as 0. Don't get worried or don't get confused. Right? In some sums like these, you might get only the value of one component, not both A and B. So automatically say the other one is 0. Okay? We use identity to solve such question. No, this is not using identities. This is actually uh, the reason behind rationalization. The identity is that, right? Oh, we are not using any kind of identity here. Those will be, I think, in the another type of questions like these. There is one more type of question. Let me see. Yeah, these ones. If x plus 3 is 8, find the value of x square plus 1 by x square. If x is equal to 3 plus 8, huh? This question seems a little funny. Let me just check. Okay. Yeah, there must be some question somewhere else. Mm, yeah, this one. Let's see this one. If A is equal to, so if they ask you if A is equal to 3 plus root 5 by 2, find the value of A square plus 1 by A square. How do you do this? Anybody? Oh, the question is missing here. I had a feeling. Okay. Oh, wait. 13th one, right? Yeah, no, the question is correct. Oh, you can't see the question. Okay, there might be, I'll write it here. Yeah. So they even ask you questions like this. If A is equal to 3 plus root 5, sorry, root 5 by 2, find A square plus 1 by A square. Okay, now can you see the question? Yes, Aditya Mundra, you have solved these questions. I had given these as homework also. I remember. We had solved and we had covered all these things. So this is just basically like a recap. So I'm just going to touch upon the different concepts. Okay, in this case, it's simple. You just substitute it here, right? You don't have to do anything. Just substitute the value of A here. In case if A is given like something, let's say 3 root 5 plus 4 by root 15 or something like that, root 15 minus root 2. Then you rationalize the denominator first, and then the value you get, you put it here. Okay, then it will be easier. Right, because if you go to take square or here, then it will get more complicated. So that's all. We've covered these kind of sums. Okay, so that covers rationalization. Then the next we have is exponents, right? I'm going to quickly write the different Shakti did not understand the last question. Okay. Okay. What part did you not understand, Shakti? So it's given something like, where is it? Yeah, is equal to 3 plus root 5 by 2. And they want you to find A square plus 1 by A square. Okay. In this case, there is no need to perform rationalization because the denominator is a rational number. Okay. Is my voice clear now? Okay. Yeah. So this denominator is already rational. So all you need to do here is just substitute. So it will be 3 plus root 5 by 2 square. Okay. Plus 1 by 3 plus root 5 by 2 square. And then you put it separately like 3 plus root 5 square by 2 square plus 1 by, or you can put 2 square up here and 3 plus root 5 square. Then use identity to expand it. That's it, you'll get an answer. Is rationalization required in this? No. No, use identity to expand it. Did you get it, Shakti? This is all. This is a simple question. Yeah. Okay. What I was saying was in some cases they might give you some A where you need to rationalize before substituting. That's all. So just be careful of that. Can you solve further? You want me to solve further? Okay, sure. This will be what will it be? 3 squared plus root 5 is nothing but 5 plus 2 into 3 into root 5 by 4 plus this will be 4 by same thing 3 square plus 5 plus 2 into 3 into root 5. Right, so what will we get? 9 plus 5 plus 6 root 5 plus by 4, and this will be 4 by the same thing here. So yeah, then you can take it 9 and 5, it will be 14, right? And you can take 2 common out and then cancel the denominators. You will arrive at a term. Okay. Okay, so the next part which we were going to cover was exponents. Exponents, right? Have you written the important formulas somewhere of exponents? I had mentioned them in the PPT if I remember. Yeah, you have. Good. So I remember I had mentioned them in the PPT when we were doing this chapter, right? Yeah, you would have. So I'll just make a quick note here, just the few important ones which are there. Just make sure you have it written somewhere. an is nothing but an plus n. So right, this when a term like this is given, this is the base and this part here is the exponent, right? Yes, awesome. Okay, so you know this, so this is, and just erase this quickly. Nope, sorry. Let me write it again. Okay, a to the power m, a to the power n. This is same base, so you add the powers. This is multiplication. Okay, the same. What do I say? They are multiplied. The powers are multiplied here. Then if it is something like a to the b to the power m, which it can be written like this, right? And the other important property which is going to come handy while solving. Okay, yeah, one more is there. If it's a to the power n and a to the power m, you can write this as the power n minus m. Okay, and this is the important one which is going to be helpful, right? A to the power x by y. This property, the last one, is used in a lot of sums involving cubed root or nth root of some number, right? So this can be written as 3 to the power 1 by n. This is the application of this one. So this is the most important one. Okay. I'm talking about the laws of exponents only. What happened, Aditya? You have written these down, right? You all have solved questions on all these things. Yes? No? What happened? It's feeling. Are you all there? Are you all listening? Is everything clear? Yeah, you would have done this identity because this is the one which is mostly used. Yes? Yes, it's easy. Yeah, but ensure you remember these laws. Okay? Okay, so I'm guessing yeah, I'm not getting any response, which means yeah, you've done this. And should we like take a question? Okay, what should I take from here? Yeah, here we'll take this one. This looks pretty difficult. Let me just write it. It's fourth root of 81 minus 8 into cube root of 216 plus 15 fifth root of 32 plus 225. Okay, so this is the question. First thing what do you do is you find out the prime factors. Okay, so I'm going to start one by one. How do you find prime factors? Like this. So it's 9, right? Sum of digits is 9, so it will be divisible by 3. 3 2s are 6, 21 3 7s are 3 9s are 3 3s are 3 1s are, right? Then 216. Again 3 divisible by 3, 7 2, right? 3 again, yes, 7 into 9, so 3 2s are 6, 1 3 4s are 12, 3 8s are 24, 2 4s are 2 2s are 2 1s are, right? So say 32 also, 2 16s are 2 8s are 2 4s are 2 2s are 2 1s are, and 225. 225, if you remember, make it, I think it will be a good practice if you memorize the squares of at least 1 to 20. To 20 is a good thing. So, make it a daily practice of writing squares of numbers, writing all the identities like a plus b, a minus b, right? A plus b the whole square, obviously, that's what I mean. Those identities which we covered yesterday, these laws of exponents, like write these at least once in a day. Okay, initially you might have to look and write, but after 2 3 days you will memorize it by yourself. It will be like, writing is a good way to learn easily. So do that. And also write the squares from 1 to 20. So when you solve such questions, though, it will hit you immediately. You don't have to keep sitting and thinking that is 81 a square or not? Is 225 a square or not? Okay, 216 is a square or not? Right? 32. So it will come to you pretty fast. Otherwise, you have to sit and, do what I'm doing, like take the prime factors, okay, and then analyze everything and then do. So we know root 225 is the root of 15, so I am not doing the whole thing process here. You can do it if you want. Okay, so fourth root of 81 means it can be also written like this, right, from the property which I just showed. And similarly these can also be written like this, plus 15. Oh, sorry, there will be no, yeah, there will be no root sign here. So it will be 32 to the power 1 by 5 plus. So if it's root, it's automatically 1 by 2. Okay, by default. Okay, some of you are solving it. Yeah. Okay. So it says fourth root, right? So if you see here, 3 to the power 4, right? So basically what your aim is after this is for all those of you who feel stuck, all those of you who are good at this, all these things, you can follow your own way. But those of you who feel stuck, this is a shortcut way to help you out. So when I say 1 by 4, my job or my main objective here is to get rid of this power. How will I get rid of 1 by 4? When I multiply something with 4, right? So it will become 4 into 1 by 4, which will become 1. That's how I get rid of it. This is the same logic I'm going to apply to all the powers to get rid of it. Okay. So if you see here, The prime factors are 3 to the power 4, so I can write 81 as 3 to the power 4. I'm going to write 4 inside and outside 1 by 4 and 8. So 216, I'm going to write it in powers of 3. So if you see here, 2 into 2 3 times and 3 3 times. So it's going to be 2 into 3, okay, bracket 3 and put one more bracket outside here, bracket 1 by 3, right? Plus 15 into 5, 1, 2, 3, 4, 5, right? So it's 2 to the power 5, 1 by 5 plus 15 square 1 by half. Got it till here? Yeah, easy. Okay, I see some of you are solving, so that's good. Solve on your own, that's great. Yeah. So now I'm achieving my objective. It becomes 1 by 4. I'm doing this so that you understand how this works, okay? So you can follow this method for all the sums involving exponents. 6, 3 into 1 by 3, right? Plus 15, 2, 5 into 1 by 5. Always go stepwise, you are prone to making less mistakes. Once you gain confidence, you can skip all these things. So it becomes 3 minus 8 into 6 plus 15 into 2 plus 15, right? So this is nothing but, have I made a sign error somewhere? Oh. Okay, so this is nothing but 3 plus 30 plus 15 minus 48, right? If I'm going to add, it's going to be 48 minus 48. The answer is 0. Awesome. Okay, answer is 90. Abhi, check how. Yes. So I believe, yeah, when we were doing this, Arav, yes, your answer is right. So when we were doing this number systems initially, I remember few of you were having doubts. You had asked me also later. So I hope it's clear now. How do you do it? Okay, write down the steps in words if you want, but this is what you do. First, find prime factors. Find the factors of the number, prime factors. How do you do it? This method. Okay. Then next step is the part to get rid of the power. Okay, do that. And then simplify. That's it. Take it one step at a time. It's easy. It's not, something difficult. Like in the beginning, this question looked like something, oh my God, so difficult, isn't it? You break it down and you solve it. It's easy to solve. Okay. Yeah. So I hope, please make a note of this somewhere. Write it down like I'm saying. Okay. The steps are first find the prime factors, then get rid of the power and simplify. Yes, I'll wait. Yeah, I'll wait, Shakti. No worries. I was just repeating the steps. Okay. So whenever you see exponents, awesome. Good thing you're writing all these things down. These are like what I might not say tricks exactly, but a simple way to do things where you get stuck, because I know roots, exponents are really scary sometimes, isn't it? Yeah, sometimes you might just see the question and go blank. Okay, what is this? So never fear now. Break it down into steps like I'm saying. You'll be able to solve all the questions. Yes, Abir. Yeah, they get easy by factorization, because then you can see that, oh, 3 to the power 4 is giving you the same thing. That's how I can get rid of 1 by 4, right? That's why I'm saying the last property of y root of a to the power x, that law of exponents comes in handy. That is used, that is the most widely used property actually. Most of the questions will have that, right? Shakti, are you done? Can we go ahead? I still need to explain to you all three things, right? Yeah, three more concepts. Awesome. So you're done. Three more concepts and then two polynomials related doubts which you gave me the worksheet for. Okay. So the next one is, what happened? It's not working. Oh, yeah. Eighth one is locating a rational number on a number line. Okay. Miss, we are doing more sums because I think we are left with three more. Huh? Those sums were necessary because I wanted you all to, familiarize yourself with the steps. Yeah. So no, we will be doing now. There are not many sums to do now. I'm just going to explain to you how do we do this. I'm going to expect you all to solve at least 2-3 questions of each concept after class today. Right? So it will be fresh in your memory. Get confidence. Oh, you don't have successive magnification, is it? Is it the ones who have exams? Let me know. Only Abir is telling me. What about the others? Do you have successive magnification or not? We have studied. Okay, so for those of you who don't have it, this will be like an extra knowledge, but some of you are saying you have, so I'm just going to cover that also. Okay. Okay, awesome, awesome. I'll cover it. I'll cover it. No worries. For the ones who you don't have, it's like extra information. It's not going to harm you. It's the simplest one actually. So yeah. So this is locating irrational number on a number line. This is by using, what do we use here? Pythagoras theorem. Right? Use Pythagoras theorem. Okay. So for example, let's say the most commonly used is root 2. How do you locate root 2 on a number line? Simple. First draw a number line. Okay. And ensure that the divisions between these two, these are equidistant. So all these divisions should be equidistant. There shouldn't be like suddenly one is far, one is close, something like that. Okay. Yeah. So for this, what do? You break it up to the nearest square first. So I can say that 1 square plus 1 square will give me 2, right? So this will be nothing but hypotenuse square, right? Or h square is equal to 2 or h is equal to root 2, right? That's how we are going to plot. So now these numbers which you have used, so the tip here, I won't say trick exactly, but the tip here is okay. The tip here is that you are going to look for these numbers, the numbers which you are going to square to get that. So here is 1 and 1. So I'm going to locate 1. I start from 0. I locate 1 on the number line. Then you are going to draw a perpendicular either with the help of a protractor or with the help of by making arcs. You know, right? How do you make a perpendicular using arcs? Yeah, you take your compass with a suitable radius, mark an arc here, and take a compass with the same radius and mark an arc here, and then join this, you get a perpendicular, right? So either use a protractor or use a compass. That's how you make the perpendicular in this case, and mark the same 1 unit. So mark this same distance here. You can use your compass and mark that, right? And then join this. So this is 1 centimeter, this is 1 centimeter, and this will be root 2, right? Spiral method, is it? I'm not really sure what is it known as. There is one more method, bisection method, right? Some bisection method also that's used for geometrically locating irrational number, right? And this is for just locating, I don't know, that said geometrically and this said just locating. Yes, Selena, I'll show you for root 5. I'll show you for larger numbers also because that's where you get confused. Okay, so the next step, you got this. So you want root 2 on the number line. So let me mark this as A and this point as B. So take AB as a radius. Keep compass on A, point A. Keep the pointed end here. Take AB as radius and draw an arc. So this point where it cuts the number line is going to be root 2. Did I draw it too short, too small or something? Is it understandable? Yes, bisection method can be used for decimal points also. Yes, you're right. Yes, Nikki. Yes. Okay, so basically you remember how do you do this, right? And if the next question is root 3, root 3 के लिए what do they use? They use the closest square as 2. So they say root 2. Root 2 plus 1. So which is going to give you nothing but 2 plus 1 or 3. If hypotenuse square is 3, then hypotenuse is equal to root 3. Right? So in this, what do they do if you are given something like if they ask you root 2 and then root 3, what do? You take this line, this root 2 line. Let me just zoom in. I think I can zoom in. Yeah, I can zoom in. So we just take this line, this root 2 line as our reference. Okay, and draw perpendicular here like this. Okay. So this is already root 2, you need 1 unit. Again, measure this unit and mark 1 unit here. And then let me just take it a bit higher for this case. And then I'm going to erase this. Join this, right? This becomes root 3. This, let me write it again. This is root 2, okay? So this becomes root 3. So what do? You take an which color should I use? Okay, you take the compass here and take the radius as AC and you draw an arc. So this becomes root 3. Okay, root 3. Okay, do you want me to explain it again? Okay, what I'll do is I'll draw a bigger diagram and explain it to you again. That will be better, isn't it? Okay. No, no, no. My right hand is not. Okay, I'm going to take bigger divisions this time. Let's say this is 0, this is 1, this is 2, this is 3. Okay, so for root 2, what do? You take this as 1 unit, draw a perpendicular either using a protractor or the arc. Okay, you draw that arc using a protractor or using arc method. Right, then you mark, so this is also supposed to be 1, this is also supposed to be 1, so mark 1 centimeter here and join this with the help of a ruler. Okay, this will be root 2. Right, now in case of root 3, I'm going to take this pen. In case of root 3, so this is a perpendicular for this. Root 3 is nothing but root 2 plus 1, right? So you make a perpendicular here, taking this as your baseline. This line here as your baseline, you draw a perpendicular This is not looking like a perpendicular, sorry. And it's 1, right? So again you measure this distance here on the number line. This will be 1. Mark 1 here and then join these using a ruler. Yes, okay. So this becomes again 1 and this becomes root 3. Okay, why have we done this and not taken it here is because root 2 is already existing here. So it's easier to take this and measure 1 centimeter and get root 3 here and then get the R instead of, you know, taking root 2 here because it will get messy. Then you have to take root 2 here, then 1 here, and then draw an arc. You will get the same thing. Got it? So for root 2, you take this point like AB as a radius. This is C. So AB will be the radius, and I'm going to cut the number line. So this point where it cuts the number line is root 2, right? So what you can do is you can also take this as root 2. Instead of taking this hypotenuse, you can also take this as root 2 and draw a perpendicular here. Mark 1. Okay, how should I show it to you? Yeah, take this as root 2, mark 1 here and join here. You should get when you take this as B. So my point is AC should be equal to AD. So if whether you do this or you do this, the point you are going to get here as root 3 is going to be the same. You got it, right? If they ask you to find root 3 directly, then you have to do this because you need to have root 2 first. There involves root 2. Right, root 2 plus 1 will give you root 3, so you will have to locate root 2 first and then locate root 3. Ma'am, is spiral method necessary if we are doing normal location of irrational? Okay, I'm not really sure what is spiral method. Is it the one where you draw a semicircle? Are you talking about that, the bisection method? No, okay. No, then what is the spiral method? Do you want to tell me? Okay, what I'm doing now itself. Okay, this is the spiral method. It's not in the syllabus. That's strange. I can see it in NCRT and it is. Okay, for some of you it isn't, some of you it is. Okay, just note this down somewhere and keep it with you because it's there in the NCRT. Yeah, okay. All these concepts, even successive magnification is there in the NCRT. Okay, so this method is known as locating irrational number on number line. I'm not really sure what other name this has, but this is what we are covering. Okay, so now moving on to the next part. If you get questions like root 17, closest square is to 17 is 16, right? 16, right? 16 plus 1 will give you 17. Or you can write it as 4 square plus 1, right? So plus 1 square is equal to the hypotenuse square, correct? So these terms here, what you write here, now these terms are supposed to be marked on the number line. So for let me do it here. So for 17, I am going to take right. I'm going to take 4 units as my baseline. Sorry, the line isn't really straight. Yeah. So 4 square and then I'm going to mark 1 square here. This will be 1. This distance is 4 and then mark the line here. So this what I get here is root 70. Got it? So you can continue doing this with for 5. Okay, for 5 it will be the closest square. What is the closest square for 5? Root 5 you all are asking, right? So 4 plus 1, closest square is 4. Always keep 1 in the picture. Just remember that. What plus 1 gives you that? That number you have to take. Okay, trick for doing this. Always remember 1 will always be in the picture. Okay, so this will be 2 square plus 1. So you are going to plot 2 units and 1 unit, not 4 and 1. 2 units on the number line. For root 5 it will be this. This will be 0, 1, 2, 3, right? So for, let me take this one. For root 5 it's going to be 2 units here, 1 unit here as the hypotenuse, and this is going to be root 5. Got it? Easy? Simple? Ma'am, in R3 there were 2 units, right? Huh? No, in R3 there is no 2 units, it's root 2 units. See, if you see closely, I have taken root 2 here, and 1. No 2. Ma'am, can you do root 3 again? Okay, you are getting confused again. Okay, so I'll just clear this canvas. Okay, so I'll tell you a trick. Okay, first let me just write this down because I think most of you are getting confused there. Root 2 के लिए what is going to be 1 square plus 1 square. Root 3 के लिए root 2 square plus 1 square. Root 4 is 2 out of the question. Root 5, 4 plus 1, which is nothing but 2 square plus 1 square. Is going to be what? Root 5 square plus 1 square. Root 7, root 6 square plus 1 square. Root 8, root 9 is 3 out of the question. Are you getting it now? How do you do? Right? Yeah, you can't do it separately, Mansi. So if you see here, these ones, like 5, shall I mark it? 5, dekho. C 2, root 2, then C, then yeah, I'll add one more here. So root 10 is going to be 3 square plus 1 square, right? This is going to give you root 10. So root 10 also. These can be done individually. See, there is a whole number involved, right? If you see closely, root 2 has 1 square plus 1 square, 5 has 2 square plus 1 square, 10 has 3 square plus 1 square. You got it? The number immediately after a perfect square. Yes, yes, I'm plotting again. Definitely. I just want to show you how do we get those numbers which we are going to plot. Is this clear to everyone? How do we get the numbers? See, I've shown you till 10. You can continue it if they keep asking you something ahead. Okay? Clear? Write this down somewhere. Okay, so you don't make a mistake. So the trick here is 1 is always constant. There is 1. Always consider 1 as one term. One of the terms. Okay, this is the key point here. So that's how you're going to get the other one. So anything plus 1, you're going to get that root. Okay, and what do you plot? You plot this, the square wala number. You plot this. You don't plot 4 and 1. You plot 2 square plus 1. You plot 3 square plus 1. Okay, clear? Okay, I'll show you how to plot it. Okay, I'll take a bit. Okay, yeah, we have a ruler. I'll make use of it. She doesn't delegate. Okay, I'm not able to. No point. I'm not able to fix this ruler, so we'll just go with. Okay. So I'm taking a bit bigger scale this time so that you all can see. Okay. So all those of you who have doubt, I'm showing you how to plot root 2 and root 3 again. Okay. So for root 2, what is it? For root 2, it is 1 square plus 1 square, right? And for root 3, it is root 2 square plus 1 square. Okay. So first thing I am going to take, let me take this. So I'm going to take this as my 1 unit. Okay. I'm going to draw a perpendicular here using either a protractor or a compass. Important. Using protractor or compass. Always ensure that. Then I'm going to mark 1 unit. So this is 1 unit. Then I'm going to mark 1 unit here and I'm going to join it. Fine. This is 1 unit. This is 1 unit. Just let me name this A, this B, this C, right? So this point becomes root 2. AC is root 2. You should not stop here. You have to locate root 2 on the number line. So take AC as the radius and keep the pointed end of the compass on A, AC as the radius. Draw an arc. The point where it meets the number line is root 2. Clear? Till here, how did I get root 2? Anybody, any questions? Let me know if you have any questions. Clear now? Okay. Okay. So the next step is root 3. So we have plot root 2 here, right? So this is the root 2. So now I'm going to take, it's difficult to measure root 2 on the perpendicular, right? So I'm going to take this base which already is root 2 here. Make use of this line. See, I'm making it in blue now so that it's clearer. Okay, and I'm going to draw a perpendicular here like this. Oh. Movies and good makeup, but not the song. Okay, it's not come out like a perpendicular, but yeah. So this here, so you make a perpendicular here. Okay. Okay, and now you mark 1 unit. Take this thing as 1 unit, this measurement as 1 unit, and mark it here with the help of an arc. And then you join this. So this is 1 unit, this is root 2, and the distance, this hypotenuse will be root 3. Correct. Now you don't stop here. You need to plot root 3 on the number line. So you take A, let this point be D, AD as the radius, keep the pointed end on A, AD as the radius, and draw an arc. The point where it cuts the number line is root 3. Clear now? Now you should be able to solve if they give you any number. Like I said, numbers like root 5, root 10, then 9, then what else is the square? 15, no. For the 16, right? So root 17, then 5 is 25, so root 26. All these you will be able to draw in isolation. You getting it? The numbers which are right after a square. Correct? Got it now? Anybody still having doubt? You got it? Why do we have to plot root 2 and then root 3? Yes? Okay. Anybody still having doubt? Let me know. Yeah, we have taken root 2 as base only, Elena. If you see, I have taken root 2 as the base here. See? and then drawn. This is a more accurate way of making it because you'll make less mistakes. If you have made a mistake in plotting root 2 on the number line here, and if you take this as a triangle, there might be more errors when you plot root 3. So this method is the correct ideal method of actually doing it, right? So root 2 is the base. That's why we've drawn a perpendicular here, right? That's why use a protractor or use the arc method, because if you make a 90-degree line perpendicular here, it is going to be a bit difficult. With ruler, you might not be able to get that precision, right? Can we do root 3 on a number line by bisection method? Yeah, I guess you can. You can do that. Kind of confusing. Ria, what part is confusing? Let me know. I'll explain it. So I think bisection method is when they tell you use the bisection method specifically, or when they say geometric, locate geometrically. Yeah, for that, when they say such things like that, you can use the bisection method. Yes, it definitely needs practice. You are going to get better. So for this, you don't even need to look for sums. Just take random values. I showed you from root 2 to root 10, right? How to do it. So like that, you calculate for root 10 to root 20, pick 2, 3 random values and try to plot on your own, right? That will be a good practice, right? Okay, so I hope it's clear now. So now I'll move on to the bisection method, right? Okay, for bisection method, let me just see quickly. Yeah, there are many. We'll take up this one only. Yeah, there are. See, when they say represent the number geometrically, represent geometrically the following numbers on the number line. Example question 1.2.11, right? So when it says geometrically, you have to use bisection method. Okay, we'll take 4.5. So what do you do? Bisection method. We are taking example of 4.5. Usually I have seen, I think that these method, ma'am, but we use any method, answer would come the same, so it doesn't really matter. I'm not really sure of that because, Abir, this method, bisection method or the geometric method, is usually asked for roots with decimal points, right? So the other one is just for normal like root 10, root 5, root 25, root 80, all those things. Okay. For this, usually decimal points are involved because that is difficult to plot on the number line, right? I'm going to write it here. Geometric method. Correct? So yeah. So for this, what do? You draw a line. I'll take green color. Okay. You draw a line and you mark 4.5 units, okay, on the line. Then what do you do? At from B, so A to B is 4.5 units, right? So from B, I'm going to take 1 more centimeter, 1 unit, sorry, not centimeter, 1 unit. Okay, and now I'm going to find the midpoint of this of AC, right? Midpoint of AC. Correct. So it will be 5.5 by 2, not 4.5 by 2. 5.5 by 2 will be the midpoint. So I draw a semicircle. Okay. Sorry, it got a little distorted at the end. Okay, and then what do? We join this perpendicular from B to this semicircle. This is actually 4.5 units. Okay, so now let this be, say, D. Okay, okay, so we take this as the radius BD and draw an arc. Okay, wherever it cuts the number line is the required uh, this part is okay. Easy. I think this method is easier than the normal line one, isn't it? No response. Are you guys there? Yes, yes. Okay. So you got this, right? This is easy. Can you tell what radii I use? Yes, sure. I'll explain it to you once more. Should I? Okay. So you need to plot root point 4 root 5. Square root of 4 root 5. Sorry. Yeah. So you draw a line. Okay. Then you mark. You can mark the uh, units here. Okay. Mark. I'm going to just erase this. Okay. So I'm making 4 root 5, right? So I draw a line, take A to B. This is 4.5 units. Okay, you can mark the divisions here like 1, 2, 3, 4. Okay, you can do that also. Now you mark 4.5 units. From B, from the end of 4.5, you mark 1 unit. The same measurement. Okay, so now here, see, if you have taken something like 1, 2, 3 and 4, suppose. Okay, so keep this unit also same. That's what the unit means, that whatever you have used here, you continue using the same set of units throughout. So this will be 1 unit. Okay, so now you take the midpoint of AC, midpoint of AC, which is, let's say, suppose here. Okay, somewhere here. So it will be 5.5 by 2 basically. And then you draw a semicircle. You got it, right? So A to C, then you find the midpoint, which will be O, and draw a semicircle. Now you draw perpendicular BD, let's say. Okay. Now you use BD as the radius. BD as radius. And draw an arc here. So now this unit, this from B to this point E, I'm going to say, right? This is corresponding to 4 root 5. Okay. Clear, Shakti? Is it okay now? Everybody, is it okay now? So I think this method is used whenever they ask you something like locate geometrically or locate using dissection method, or if they are giving you decimal points, right? 3 ways, 3 pointers you look at. Okay, what are the 3 pointers you look at? The word geometrically, the word bisection, or you see a decimal point. Correct? I don't think you can locate a decimal point using the previous method which we used. Okay, so those are for direct like the numbers, whole numbers. Okay, so since you all are claiming you all understood, I am going to uh, hope that you solve questions on these concepts today itself so that it's yes, I used semicircle AC nahi OC, midpoint of AC as the radius. That's how I'll get the semicircle. Now if I use AC as the radius, it will go somewhere else. Yeah, it will become big. Shakti, I'll show it to you once more. Okay, so this is the line. Say this is A to B and this is C. So I'm going to find the midpoint here. O. So this AO is going to be my radius. Okay, Shakti. When I take AO as the radius, it will give me a semicircle which touches A and C both. Right? If I take AC as the radius, it will go somewhere else. Yeah. You can use protractor or arc method for drawing perpendicular. Here we are drawing semicircle. Okay. Okay. So the last point is the last topic we'll cover is successive magnification. Okay, very simple. There is like I don't know which number it was. Let's say maybe 9, I guess. Hmm? Successive magnification. So what do? They will ask you questions like let me just search. Yeah, visualize 3.765 on the number line. So we have the example here. Visualize 3.765. So in this method, what you need to note is that A, you have no under root. Okay, you will not be having square root of anything. B, there will be many points. Should I just write it down here? Should I? Okay. No square root, right? And B is many digits after decimal point. Okay, these two keywords are what you need to look at. That's when you use this successive magnification, because they might not use the term successive magnification. Okay, so what are the steps you use for successive magnification? It's very simple. Oh, what is successive magnification? You're asking me. Ryan, I'll just explain it to you. You will get the hang of it. Okay, but key points to remember, uh, when they say visualize, when there is no square root and when there are many digits after the decimal point, you are going to use successive magnification. Okay, I hope you'll remember that. Okay, so first step is I'm going to draw a number line and then I'm going to mark 0, 1, 2, 3, 4. So 3.7, I'm going to look at the first two digits, which is 3.7. So it comes between 3 and 4. So I'm going to make 10 divisions here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this is going to be 3.7. Okay. So I got 3.7. Now my second step is going to be is locating 3.76. So I am going to magnify this area. This is how they denote it in your textbook, workbook also, and in NCERT also. So I'm just denoting it the same way. So they make something like this. so that they're showing that they're magnifying it, right? So 3.76 na, so I'm going to make 3.7 here and 3.8 here, and so you basically magnify the number line. That's what successive magnification is. So 3.7, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, one more need somewhere. Okay, so 3.76, 1, 2, 3, 4, 5, 6. So this is 3.76. Okay. If you write just this or if you show it in bold is fine. So make sure you've written these two. You've written whatever I'm writing as the number line. Okay. Then third step is, so we got 3.76. Now we want 3.765. So what do we do? Third step. Third step, we are going to 65 ना, तो 6, 7, 6 और 7 7 के बीच में आएगा, correct? Between these 2 points. So I'm going to draw something like this from here, which means I'm magnifying these 2 points. And this is going to be 3.76 and this is going to be 3.77. You got it right till here? So now I'm going to make 10 equal divisions here. Okay, finally equal divisions. Okay, 3.675. So this is 3.67. Should I write it here? So this is 3.761, 3.762, 3.764. You got it right. So this is 3.766. Oh, this is the one we want. 3.765. Okay, this is called successive magnification. So basically what you're doing is you draw a number line and then you magnify it till you achieve the point you are looking for. So what are we looking for was 3.765 and we successfully magnified the number line to point out where it falls. Easy. There's like not much funda going behind this. It's just any doubts? Anything? We will be done when you all get this, when you tell me you understood this. Then I want to discuss one more point. So give me more 10 minutes. No doubts? Okay, you got it. All those of you who asked me, Ryan, you asked me what is successive magnification. Did you get it? You understood. Awesome. Ryan, did you get it? I'm not getting any response. Finally. Yes, Ryan says he got it. Okay, so basically, let me do a recap. Give me more 10 minutes, okay? Just 10 more minutes, please. I want to do something important, okay? First thing is I'm just going to write down whatever. This is like a recap of what we did just now, right? What is the first thing? Identifying rational, irrational numbers, right? Second part, what we do is, what did we cover? Yeah, how to find rational, irrational numbers between two numbers, right? Then what did we do? Operations. Oh no, before that we did a lot of many things before operations. Sorry. Yes. We did decimal expansion, right? Decimal expansion of fractions, correct? Then what did we do? We expressed recurring decimals as p by q, right? Using the method where we use x. Then what did we do? We did operations on rational and irrational numbers, correct? Then what did we do? We did rationalization, wherein if we get something on the RHS, how do we get those terms? We did that, right? Then what did we do? We did exponents. Exponents. Then locating irrational number square root on number line. Correct? And then we did bisection method. And the last one which we did was successive Okay, so this is what we covered today, right? I hope you can, when I'm writing all these things, you can remember what all we covered, correct? Okay, so Shakti had sent me a worksheet this morning regarding polynomials. So most of the questions I found there were easy to do, like based on, just little tricks involved. But there was one question which I'll just tell you. Uh, Give me a second. Yeah. So there was this one question. Yeah. Determine what must be subtracted. What what must be subtracted from 4x cube minus 16x square plus x minus 5 to obtain, I'm just writing okay, polynomial, which is divisible by x minus 5. Okay, so when they ask you some question like this, you must always remember this, what I told you to remember that day, yesterday, sorry. Okay, remember this? Okay, so what is the catch here? What must be subtracted? So this is the dividend or p of x, right? So if I am going to subtract the remainder, if I take the remainder this side, I am going to get g of x into q of x, which means this is a factor, right? This is how you solve the sum. So you are going to divide x minus, you are going to perform long division, correct? You are going to perform long division. Remainder is the answer. So long division, you do long division, you get a remainder. Okay, the remainder you get is the thing you need to be subtracted, which needs to be. Okay, yeah, and there was one more question on the same line saying what must be added to a polynomial. So same thing, just remember this. That's why I told you yesterday to remember this. This is a key formula. This will help you in understanding almost all questions. Right? Dividend is equal to divisor into quotient plus remainder. Okay? Cool? Yeah? Okay, but the rest of the questions are fine. Yeah, that's cool. Okay. Okay, so just keep this in mind because they might ask you, they didn't understand the addition part. Okay, Elena, so if you see this polynomial which they have mentioned here. This is the dividend or nothing but p of x, correct? So we know this relation that dividend is equal to divisor into quotient plus remainder, correct? So I'm just taking remainder that side to the dividend. So it's basically this is nothing but dividend minus remainder, okay, right? This is all I've done. I've just taken the remainder to the LHS. Okay. So dividend minus remainder, which will give you divisor into quotient, right? Divisor into quotient, correct? Okay. So when there is no remainder this side, so it's going to be a factor, right? So when they say subtracted or added, if they say added, what must be added? The remainder must be in negative form, or you might get uh, a remainder like say minus 90. Okay. So now minus 90, so it will be nothing but p of x minus of minus 90. So you're basically adding it, right? So that's all I'm saying. So you use the exact same thing what I have done here, but when they say what must be added, you might get the remainder in a negative form. So that's why you add it. Okay, is it clear now? Okay. Okay, then guys, if you clear, you don't have any doubts, you can leave. I just wanted to explain this part. Elena, did you get it? Yeah, for addition, most probably the remainder will be negative. That's why you add it. Bye bye. I hope you're going to practice these questions. Got it? Nice. Awesome. Chalo, bye bye.